Today we're going to take a look at this question where we're given that a and b are two real numbers. We want to show that if b is bigger than a and that a is bigger than 0, we want to show that b squared is bigger than a squared, and square root of b is bigger than square root of a. And before we approach this problem, look at my red pen writing. So we have two properties that we want to know before we actually can try to prove this, right? So the first property, that if b is bigger than a and that c is bigger than 0, then cb is bigger than ca. So let's use some actual number as an example, right? So let's say we choose a equal to 2 and that b is equal to 3 and that c is equal to 4, right? So we can see in this case that indeed that ca is smaller than cb because ca is 8, because 4 times 2 is indeed smaller than 4 times 3, which is 12, right? So it satisfies this, the properties in this case that we're using. And our second property is that if b is bigger than a and c is bigger than b, then it's guaranteed that c is bigger than a. It also works in our example because we have our b, which is 3, is bigger than our a, which is 2. And then we have our c, it's 4, which is bigger than our b, which is 3. And then we can also see that 4 is indeed bigger than a. So that's what these two properties says. Okay, so let's actually get to the question now. So we want to first show that, let's divide this into two parts, where the first part we show that b squared is bigger than a squared. And the second part we show that square root of b is bigger than square root of a. So in the first part we want to show that if, so we're given that if a is bigger than 0 and b is bigger than a, want to show a squared smaller than b squared, right? So how will we do this? Well, we do this first by using our property 1. But in this, so we're gonna pick a c and then gonna multiply through our whole inequality right here, and then you'll see what I mean. So let's write that. So a is bigger than 0 and b is bigger than a. So let's say in this case we choose our c to be a, okay? So a times a, so choose c equals to a. So c times, so we know that b is bigger than a, so cb must be bigger than ca. And in this case we have our c is equal to a, right? So it will be a times a smaller than a times b, which means that a squared is smaller than ab, which is true. If you use any other numbers, you can always substitute and try it out, and this will always be true. And let's, now that's for c as a. So what about now we choose that c is b? C is b, okay? Then we also know the property is that ca is always smaller than cb. Same property, but in this case that we choose c as b, then this will just becomes b times a smaller than b times b, which means that ab is smaller than b squared. So what do we have here? Let's use our green pen, and you can kind of see that what we have here is that a squared is smaller than ab, and that ab is smaller than b squared. And look at our property 2, is that if we have b is bigger than a and c is bigger than b, then c must be bigger than a. And in this case, it's not hard to see that our b is our ab in this case, and that our a is the a squared, and that our c is the b squared. So by property, property 2, a squared is indeed smaller than b squared. So that will be for the b squared bigger than a squared one. So we can now get to the second part, which is we want to show that if 0 is smaller than b, square root of a smaller than square root of b. So how will we show this? Well, we first kind of want to arrange an inequality first. So what do we have? We have A is smaller than B, right? This is given. So this implies that B minus A is bigger than 0. If you know, like if you learn in like a basic algebra, that when you manipulate it like this, the sign flips. Okay, so B minus A must be bigger than 0. So what does this imply? This implies that B squared minus A squared must also be equal to 0, because you're squaring both of them, right? And then B squared is always bigger than A squared because B is bigger than A. Then we want to introduce something that we also learn in algebra, is that if we have x squared minus y squared, it is equal to x plus y times x minus y. So in this case, our b squared minus a squared becomes b squared minus a squared bigger than 0 becomes b plus a times b minus a bigger than 0. Okay, so and then we can further change this. Let's actually write it down. B plus a, b minus a bigger than 0. So we can further add a square root to it, and it will also be true. So square root of b plus square root of a times square root of b minus square root of a is bigger than 0. So as you see, we didn't even change anything here, because all our like changing from normal number, changing from like a real number to like a square root, adding the square root sign, they're all true, because they're all based on the fact that b is always bigger than a. So we can do this manipulation all right, and it will not be wrong. So our next step is to use our property A, which is kind of confusing because the C we choose here is actually, that's right, C equals to 1 over 1 over square root of A plus square root of B. So if we choose this thing over here as our A and 0 as our B, and the property says that CA is smaller than CB, and then in this case, what is CA? Well, CA, let's write it down. CA is 1 over negative A, I keep adding the square root sign. Negative A plus, square root of A plus square root of B is times square root of B plus square root of A square root of B minus square root of A bigger than 1 over square root of A plus square root of B times 0. So as you can see that the square root of A and plus square root of B, it cancels out with this. And then this will just become 0, because anything times 0 is 0, right? Especially if you have a 0 on top of it. So this then ultimately becomes square root of B minus square root of A is bigger than 0. And then, which then indicates that square root of A is smaller than square root of B. And that will be our completion for this proof right here, by using simple manipulations of inequalities and that properties of numbers. So that will be our proof for this question.